Assalamualaikum. In this one video we will solve G part of question number 6. So this is our G part. First of all we will separate the power of individual terms. Like in our first step we will separate all the powers: a cube whole power minus 8, b minus 4 whole power minus 8, c minus 1 raised to power minus 8 plus its power is 2, so a square whole square, b raised to power 0 square, c raised to power minus 2 square. Now here we will use the law of multiplication, product law, sorry not product law, law of power, because it's power of power, so we will multiply the exponents. So a raised to power 3 multiplied by minus 8, b raised to power minus 4 multiplied by minus 8, c raised to power minus 1 multiplied by minus 8 plus a 2 multiplied by 2, and any number having power 0 is always equal to 1 square, and c minus 2 multiplied by 2. After this we will multiply the terms: a raised to power minus 24, b raised to power minus multiplied by minus plus 32, c raised to power 8 1 जा 8 and minus minus plus a 2 2 जा 4, 1 1 जा 1, because its power is 2, so 1 will multiply it by itself, 1 1 जा 1, and when 1 will be multiplied by a square or this one term or this one term, then these terms will come as it is, and c raised to power minus 2 2 जा 4. After this b 32 c raised to power 8 over a raised to power 24, because this one a raised to power minus 24 is negative exponent, this one term having negative exponent, so we will use the law of negative exponent and take its reciprocal, plus a4 over c raised to power 4, because these are negative exponents, so we want positive exponent, then we will use law of negative exponents. Next h part is 5 raised to power 10 plus n multiplied by 25 raised to power 3n minus 4 over 5 raised to power 7n. So in our first step we will write it like this: 5 raised to power 10 plus n, and we know 25 is the perfect square of 5, so we will write it like this: 5 raised to power 2, because 5 5 are 25, and we are going to simplify it, so this is the reason we will write 25 equal to 5 square, 5 raised to power 7n. After this, in our next step we will separate all the exponents. 5 raised to power 10, this is 10 plus n. Here we will use the law of product law, same basis powers will add, but in this one case we will reverse the case and we will write it like this: 5 raised to power n. See, bases are same, so if we add powers, then 10 plus n, it will be equal to this. So this is the reason we have separated the exponents with bases. Multiply by 5 raised to power 2 3n, 5 raised to power 2 power of power, so we will multiply the exponents 2 into 3n minus 4 over 5 raised to power 7n. After this we will write it like this: 5 raised to power 10, 5 raised to power n multiply by 5 raised to power 3 2 the 6n, and same we will separate the bases: 5 raised to power 4 2 the 8 of minus 8 over 5 raised to power 7n, because we can separate it if if a raised to power, here we have used the formula a raised to power m multiplied by a raised to power n is equal to a raised to power m plus n. If this one side is equal to this, then obviously this one side is equal to this. So this is the reason I have separated the these exponents. You can see here powers are added, so reason behind it is this. Now I will combine all the terms having power n. 5 raised to power n, 5 raised to power multiplied by 5 raised to power 6n and multiply by its in denominator. When I will write it in numerator, then its exponent's sign will change and it will become 5 raised to power minus 7n. Now multiply 5 raised to power 10 multiplied by 5 raised to power minus 8. These are the exponents that are in the form of number, and these three bases have exponents of variable in the form of variable. So same basis, power will add 9 plus 6n minus 7n multiply by 5 raised to power 10 plus minus 8, like this. After this, 5 raised to power 6 plus 1 7, 7n minus 7n multiply by 5 raised to power 10 plus minus minus 8. So 5 raised to power 0 multiply by, because same numbers but having opposite signs, this one is of plus and this one is minus, so we'll cancel it. 5 raised to power 10 minus 8, 2 is equal to, any number having power 0 is always equal to 1 multiply by 5 raised to power 2. When we multiply any number by 1, then answer is that one number, 5 square, and this is equal to 5 multiplied by 5 and 5 5 the 25. Done. Last I part of question number 6 of exercise 4a is 1 minus curly braces 1 minus n raised to power minus n raised to power minus 1 and whole term raised to power minus 1. It is negative exponent, so first of all in our first step we will take its reciprocal by using law of negative exponent. 1 over 1 minus n raised to power minus 1 curly braces raised to power minus 1. This one reciprocal I have taken of this one minus 1. So all the terms will come as it is in denominator. I have taken just the reciprocal or inverse of this one minus 1. After this I will 1 over 1 minus. Now I will solve this one minus 1 power negative exponent, and this one negative exponent is of only the terms that are in curly braces, not the complete term. So I will write it again, 1 over only this one term that is in curly braces, 1 minus n raised to power minus 1 by using negative law of exponents. After this I will take LCM of my denominator. When I take the LCM, it will be like this, 1 minus n raised to power minus 1. Its denominator is 1, so this one term will come as it is, 1 minus n raised to power minus 1, and this one minus of formula and this one 1 as it is. Now this one 1 will be cancelled with this one 1 because of opposite signs. After this you can see it's our numerator, and in our denominator it's a fraction, and it is the rule that we use in mathematics that if we have any fraction in denominator, then its then the denominator of fraction, that is in denominator, will multiply it by the numerator. So we will multiply it with 1, only this one term, so 1 multiplied by this one full term, 1 minus n raised to power minus 1 over this one term will left, minus 1 minus n raised to power minus 1. When 1 is multiplied by any term, any number, then that number comes as it is, 1 minus n raised to power minus 1 over minus 1 minus n raised to power minus 1. Now I will separate these terms, like I will write it 1 over minus 1 minus n raised to power minus 1, means to say I will write the denominator with 1 separately, and then this one minus sign, and then with this one term 1 minus n raised to power minus 1 over minus 1 minus n raised to power minus 1. I have separated both terms of numerator with denominator. After this you can see these terms are same, so here we use the rule of signs of division. In our numerator there is plus and this is minus, plus minus minus, 1 over 1 minus n raised to power minus 1, minus minus plus, and this one 1. So after this we will write, this one is of plus, having plus sign, so we will write it as first term and then minus sign, and this one term 1 minus n raised to power minus 1. After this I will solve this one minus sign. When I take the reciprocal, it goes in numerator and its power, that is negative, will become positive. 1 minus n raised to power plus 1. If I write plus 1 and not write, then both are same. After this 1, and this one minus sign is outside the bracket, it means this one sign will be multiplied by first term as well as second term. So here is plus sign, plus minus minus, 1 1 1, and this one minus with this one minus sign, minus minus plus n. Same numbers having opposite signs will be cancelled, only n is the answer. Done.